G'day, Michael here. In this Unsense video, we look at how the Earth is definitely, obviously, flat. If you go out the door, you'll notice you look either way, you might see some hills, etc. But on the face of it, what you can see is definitely flat from your perspective. And the sun can go overhead, it's a nice little fiery ball that goes overhead, and so does the moon and the stars and all that sort of guff. You can see as my desk background, I've got a flat Earth image, and you can see how one explanation of a flat Earth is this disk with Antarctica forming like a wall around the outside edge. Now, what you can also do is take photos to prove the point. Now, what starts happening is when you get distance in photos and you use the sea as a reference, you can verify how flat the Earth actually is. Now, there's a couple of beauties I have here. Now, if we look at a landscape, I've got there's a big flat area across Australia. I'll go through. Actually, I might just go full screen. You can see here this landscape goes on forever. And you can see we drove for hundreds of kilometres, and basically it looked pretty much like that across the Nullarbor Plain. I'll show you what that looks like shortly, but I'll just go further into this. Actually, here's another photo, which involves distance, but this time we have the ocean as part of it. Now you can see here there's a tiny boat in the foreground and there's some massive ships in the background. Now this is a ship loading to this other ship, and you can see their decks, their hulls and everything are completely over the horizon. So the ocean has formed a mound between us and there. And you can see a bit of a line of kind of a shelf before it goes into deeper water. So you can see this is definitely a big expanse of water. And this lens, let's just see what the lens properties are, so you can see what the conditions are of the photo. Now, I used a 300mm lens, which has a 450mm effective focal length because of the sensor size. It's sort of a 2/3 sensor. Okay, so let's just close that. So this is, one area, one way you can use as a reference to how flat the Earth is. And you see, once we start getting some distance on the ocean, of course water does its best to try and stay level, and certainly within the height of a ship it would definitely stay level. So you can see here there's quite a shape forming. Now I have other photos. If you travel, you have the opportunity of, obviously, maybe if you have a coastline available to you and a reasonable cliff area available to you, you might be able to also see some interesting features. Now this is a photo showing a cliff and the vehicle we were travelling with. In the background here I've got this is the continent of Australia, and we travelled from this end of the country to that end of the country, and there's a big patch here called the Nullarbor Plain. Anyway, that is quite a big flat area, and that's where those photos were taken. Now I'll just zoom into the area where that particular photo was taken. I'll just roll it out. There's that guy. Let's put him up there and make him a bit smaller. Okay, that's reasonably well fitted in the frame. Okay, so I'll zoom in to where that photo was taken from, and it's pretty well bang there where my mouse pointer is. Zoomy zoom. Come on, you can do it. And you can see we've really one end of the country to the other is pretty well bang on 4,000. Just make this stay on the top now. It's pretty well bang on 4,000 kilometres the road trip. So here we are. We're zooming in to the exact spot. A bit further. Okay. Now a vehicle, the red vehicle there, is parked pretty well about there. You can see there's vague line of some other vehicle parked in that space in the satellite. Well, it's probably overhead aircraft photo, but it might be a satellite image, not sure. Probably more like an aircraft aerial photo. Alright, so my vehicle was parked there. You see it there. And the photo was taken from this perspective here. So that from there to there is about 100 metres. So let's have a closer look. Actually, let's do full screen. You can see the height of the vehicle is pretty insignificant compared to the cliff face, and we certainly don't see the bottom of the cliff face. Great Australian bite, that's all good. That's where the photo was taken from, and you can see we're starting to clip the horizon, but the cliff face, what we saw in the previous photo, we'll just go back, was that. You see this black line, there's a bit of a lighter line there. That's up here at this kind of level where that other photo quit. So this is 2 to 3 times more height shown in here. Let's go get rid of that. And that represents this coastline. I'll keep zooming out until that, till we can identify enough detail on there. Okay, so the first ridgeline was that one, which is this here. The second one, there you can see a kind of foot, is that area here. And then the next one is, what are we looking at? That would be then that. Then somewhere around about here there's another knob, and that's the one far off in the distance. And then there's like a bit of a gulf. So let's just zoom out. There's our gulf. And then we see some other line which is there. And you can see, looking at this image, I might actually switch to the next one. So we had the near lot of rubble, the next 2, then 3, then 4, then the gulf. And you can look here, that's about 1/3 of the height of from here to there, just visually. So I'll zoom in a bit more so it makes more sense. So that's about, from here to here is about 3 times higher than that. So 2.5 to 3 times. Okay, now let's have a look at this. Where are we now? Photo was taken from this point, right? That last spot there. I'll zoom out again so you can make sense of it. Last spot there. Juggling these blessed screens. Here we go. Move it down there maybe. See how that works. Photo taken from here. The fourth knob was down there somewhere, which is that one. And then about 2 to 3 times the distance away we see this other line. Just zoom out a bit further. So from there to there, maybe 2 to 3 times we see this other line. So there you go, you can see that line is there. It'd be very hard to pick up exactly which one of these ripples, but I suspect it's pretty much that one. But from the perspective of how far back the other camera is, it could be maybe one of these other ones. It's a bit hard to tell. Okay, so on the other side of that kind of gulf, and then we have kind of another little shallow recessed gulf type space, and then there's another relatively a peak, so that'd be that other one in the far distance, and then it tapers away. So let's have a look at that a bit closer, and you can see how the cliff face kind of goes over that edge. Now because the road follows along that cliff line, and you can revisit the cliff quite a few times, there's even tracks further up, you can visit the coastline, you can see yourself, you can have a look at the cliff line yourself and see that the cliff is actually quite consistent in height. It's, I'm not unable to measure to the metre, but you can certainly see that it's many times the height of the vehicle, or many times the height of a man. I guess it's 50 to 80 metres. That might be the variation of it, but that's the sort of height we're talking. So this whole, it's really a plateau. Produces, you can even see kind of a shadowing from the aerial photography. And there is a bit of a lower patch here, but this line here is pretty solidly the same, and this is fairly similar and then tapers down. It's hard to explain that. But anyhow, that shows the edge of what we can see from where I took the photo. So the photo I took from, make sure I'm not talking nonsense, there, that's right, at this end. Here, you can see it's getting smaller, and there's a kind of a ridge line, and that's the limit of my photo. And that was, well, let's just see what sort of distance we're talking about there. From that photo we can definitely see, we can see from here definitely to there. I'll just now move up. That's 10 kilometers here. So from there to there is maybe 30 kilometers. keep losing that. Yeah, there it is there, definitely there. Put that on the edge. So there's sort of definitely about 30 kilometres, and maybe possibly out, if we are seeing that line, it's will actually be more like that line. It might be in the vicinity of 60 or 80 kilometres away. So there's a lot of haze. The air itself starts ruining the visibility. And there's definitely obviously something in the air like ocean, humidity from the ocean, maybe some dust, etc. But that is a long way away, 50 kilometres away, sort of 30 miles or thereabouts, or maybe even a tad further by the time it hits invisible. But we can see so far because we're so far up. But you can definitely see how there's a curvature and the continent goes over the edge, which is created by the ocean. So because it's so far up, we can see in the distance. And you can definitely see how the landmass itself has got a curve. There's a kind of a hump to the whole thing. Obviously, because we're standing on top of the landscape, it appears to go kind of from below us, then up, and then back down again. That's kind of how that works. Alright, so if you travel and have the good view of an area of the ocean, you get the opportunity to compare. Now this here is one of the landscape. And you can see sort of mountains-ish, a bit off in the distance there, but otherwise fairly flat. This is basically pretty much an nullable plain. Well, there you go. And the landscape just goes off into absolutely nothing. There's kind of an edge. And you drive for hundreds of kilometres and you see the same again and again and again. You get the very slightest of rises on occasion. But there you can also see with the ships, the moment we have some distance, we end up with a horizon. And that horizon buries things. So once you get some distance in your visibility of an otherwise flat area, you end up with realizing that there's curvature to the Earth. Another good way of telling the curvature of the Earth is if you are able to cross the equator. So starting from, we're pretty well south of the equator at about 40 degrees south, well actually 38. You know, this area here, you know, southern Australia, Tasmania. Let's see if we can get any details. Go back to the map. Do we get longitude and latitude marks? No. Well, we're about 38 degrees south. And if we look at, say, Europe, that's kind of, sort of about the same amount north. Also, North America, a good chunk of North America would be about the same, 40 degrees north. So if you're able to travel from that amount north to that amount south or vice versa, I, as a child, travelled with my father to Austria, and the sun did a weird thing for me as a child. I couldn't reconcile what I was looking at. But basically, here in Australia, because if you imagine, most of the time the sun isn't perfectly overhead because we're away from the equator, and it shows up more vividly, you know, the closer you are to like winter or yeah, the closer you are to winter in your hemisphere, the more this shows up. Now in the south, got a simulation here somewhere. In the south, I've got a Stellarium simulation running here. Allocation. Yeah, we're based Southern Australia, as you can see right there. Now let's just get this thing to run. I've set it to, let's just set it to like June, right? And the sun rises in the northeast and sets in the northwest. So kind of when you're facing the sun, you're actually looking northward. And the sun comes up northeast, sets northwest. So as you can see, looking at the sun, in winter, we're watching the sun rise in the right and fall in the left in the southern hemisphere. Now what we'll do is change it to December for the northern hemisphere. And what we'll have to do is now face south. Oh, I need to, what am I doing? I need to also set the location. Let's just pick, I don't know, Europe. Let's do that. Don't care where it is exactly. So set to 12. Yeah, that's working. And you can see the sun rises to the left and sets in the right. So if you travel a distance either side of the equator, you can see that something is up with how the sun operates. For that matter, the moon and the stars, etc. And you can also see, let's just swing around, we're in the northern hemisphere now. There'll be a point towards the north where the stars rotate, and it's roughly around the North Star. So the sun rises, sun sets, and it rotates around a spot in the sky. And if you take a photo, if you've got a camera that you can set at night to take a photo of like 3 or 4 minutes, you'll notice the stars sweep an arc. If you could do it for an hour or 2 hours with your camera, you'll notice there's like lines that are produced, circular arcs. Now let's go to the southern hemisphere. Let's go back to where we are. You might notice the landscape's going back to front again. Alright, so let's face, oh there we go, south. Yeah, let's do that. The sky rotates up in the sky. So on the south, you look to the south and the world sees the sky rotate in the sky above the horizon. And then if you're in the north, the same sky rotates in the north. So we've got the sky rotating around 2 pivot points. And you can verify this yourself with a long exposure photo. You can just point it to the sky and just let it sit open, the shutter sit open for a while. So any DSLR will let you do that, or an old film camera, any of those sorts of things. In the night sky, point at the sky, long exposure, and you'll see the trails of the star's motion. Now both the north and south have that. Now that factor is difficult to explain if you think the world is flat. You need to find a good explanation for it. But the easiest explanation is the simplest, and it really is the simplest. Let me just stop this guy, so excuse me, computer. Where are we? So the easiest explanation, switch to satellite again. The easiest explanation is that the Earth is rotating, and when you're on the northern side, it appears that the sky rotates the opposite way to which the planet's rotating. It's the easiest way to understand it. That in itself is good enough proof that the world is not as your senses see it. So if you have an opportunity to travel north and south of the equator, you'll be able to feel how the sun behaves in the sky and feel that there's something up. A flat disk doesn't give you an opportunity to explain how the sun behaves. It also doesn't give you an opportunity to explain how the sky behaves. On the face of it, it may seem attractive that this flat disk idea has some appeal because your senses tell you that what you see is flat. This channel is all about comparing your senses to what actually makes sense. Well, I guess that's it from me. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.